Fakultas Teknik Geologi Universitas Padjadjaran merupakan lembaga pendidikan tinggi yang menyelenggarakan dan mengelola 3 program studi, yaitu program sarjana dan program pascasarjana yang terdiri atas program magister dan program doktor dengan didukung oleh 8 orang profesor dan 37 orang dosen sebagai staf pengajar. Fakultas Teknik Geologi dengan visi menjadi fakultas yang berstandar internasional dan bermanfaat bagi masyarakat. Salah satu tugas pokok dalam kurikulum teknik geologi adalah menciptakan lulusan yang memiliki keunggulan dalam kemampuan lapangan, sehingga kurikulum teknik geologi dikembangkan secara terpadu dengan muatan desain penelitian, baik berupa pengetahuan, keterampilan maupun pengalaman penelitian dalam bidang geologi, sehingga mahasiswa bebas memilih dengan outcome yang lebih baik sebagai bagian dari program Merdeka Pembelajaran.
Recording in progress.
Okay, good day, ladies and gentlemen. Welcome to Webinar International Series for Green Energy for the Future. It's such an honor for me to welcome you here in this event today. I'm Kamala Wijayanti, your host today. I would like to extend a very warm welcome to all of you, both on Zoom application and YouTube Live. This webinar series is a part of 62nd Natalis, or anniversary of the Geological Engineering Faculty event that held every Saturday. Before we start, let us hear the national anthem of Indonesia, Indonesia Raya.
Indonesia, tanah airku, tanah tumpah darahku, di sanalah aku berdiri, jadi pandu ibuku. Indonesia, kebangsaanku, bangsa dan tanah airku, marilah kita bersatu, Indonesia bersatu. Hiduplah tanahku, hiduplah negeriku, bangsaku, rakyatku semuanya. Bangunlah jiwanya, bangunlah badannya, untuk Indonesia Raya. Indonesia Raya, merdeka, merdeka, tanahku, negeriku yang tercinta. Indonesia Raya, merdeka, merdeka, hiduplah
Now, I would like to greet Dr. Yuyun Yuniardi, Chairperson of 62nd, this Natalis Faculty of Geological Engineering. Dr. Yuyun, please welcome.
Okay, thank you very much, Ms. Kamala. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. To Honorable Dean of Geological Engineering Faculty, UNPAD, Prof. Mega Fatima Rosana, Vice Dean of Learning, Student Affairs and Research, Prof. Istintin Yunisi, Vice Dean of Research and Organization, Dr. Cipta Indiana, distinguished participants, ladies and gentlemen, my colleagues in Geological Engineering Faculty, the alumni, and my dear students. I'm pleased to welcome you to the 4th International Webinar of Geological Engineering Faculty with the theme Green Energy for the Future. This webinar is part of a series of online forums and discussion held to commemorate the 62nd anniversary of the Geological Engineering Faculty, Universitas Padjadjaran. It aims at providing a forum to exchange knowledge in the broad field of geology and earth science. As we have already known, great environmental footage left by the usage of fossil fuel has increased the Earth's temperatures, melted the ice in the Arctic that impacted to the increase of sea level each year. Because of this issue, innovation in the technology regarding the green and cleaner energy is very much needed. This webinar is conducted to give another insight for participants how geology could contribute to the green energy in the future, as well as tracing the possible environmental waste from industrial process and fossil fuel usage. The usage of green and renewable energy, especially in Asian region, will also be delivered to give us an understanding how it is applied, and moreover, how we could learn from it to increase the application of green energy in our beloved country. In this virtual conference room, we will hear the talks from our distinguished speakers, Associate Professor Dr. Kotaro Yonezo from Kyushu University, Dr. Zulfikar Yurnaidi from Asian Center for Energy, and Professor Venkatesan Venugopal from University of Edinburgh. I hope that the participants could extract a lot of insight on the application of green energy and environmental issues from our invited speakers and have a fruitful discussion about it afterwards. Ladies and gentlemen, I believe that by participating in this webinar, we will have a deeper knowledge about green energy to sustain our community and Earth, as well as give contribution to the advance of the science. Okay, I wish you all a very successful and enjoy this webinar. Thank you very much. Thank you, Ms. Kamala, please. Thank you.
All right. Thank you so much for your wonderful remarks, Dr. Yuyun. All right, everyone. So we have invited 3 speakers who are competent and experienced. For this session, we have 2 speakers, Associate Professor Kotaro Yonezu from Department of Earth Resources Engineering, Faculty of Engineering, Kyushu University, Japan, and Dr. Zulfikar Yurnaidi, Senior Research Analyst of ASEAN Center for Energy. And in session 2, we have Professor Venkatesan Venugopal from University of Edinburgh. Now, let me invite our moderators today. So our moderator today is Mrs. Nisa Nurul Ilmi. She is the lecturer of Faculty of Geology, Universitas Padjadjaran, in geochemistry subject. She has finished his bachelor in Faculty of Mathematics and Science, Universitas Padjadjaran, Bandung, and her master in Newcastle University, Newcastle upon United Kingdom. So for Mrs. Nisa, please welcome.
Okay, thank you very much, Mrs. Kamala. Good morning, ladies and gentlemen. I would like to welcome you to this first session of the seminar. In this session, as Ms. Kamala has addressed, we are going to have the first presentation from Dr. Kotaro Yunizu. So I am going to read his biography. So this is, should I share this? So, Dr. Kotaro Yunizu is an associate professor of Economic Geology Laboratory, Department of Earth Resources Engineering, Kyushu University, Japan. He obtained a PhD from Kyushu University in 2009 with the experiment on geochemical work on the Hishikari gold deposit, Japan. And then he also has worked on experimental and field geology and geochemistry in hydrothermal and geothermal systems. He also worked in the part of water-rock interaction, is one of his interests, and he is currently working on various REE deposits, including ion adsorption type, residual type, and carbonate pegmatite type of REE deposit. So I'm going to welcome you. Without further ado, I would like to welcome our first invited speaker to deliver his presentation. Right, Dr. Yunizu, the floor is yours.
Thank you very much for your introduction. Selamat pagi. Yeah, today I'd like to talk about REE. So I hope you can see the slide. And today's topics are geochemistry and potential for mineral resource, but a kind of review on the REE I'd like to give you. Then, anyway, congratulations on your 62nd anniversary of your faculty. It's a very long history, and I'm very happy and glad to be here on such a memorial date. So, as already introduced, so my first research topic is on land epithermal system. So this is Hishikari gold deposit. It's really high grade gold deposit. Annual production is not so much, but the average grade after 40 years operation, but still around 30 grams per ton. So it's incredible. And I expand the research target to the like soft material, so including bauxite and nickel laterite mine like this, and also go to the much frontier side for the submarine subsea floor mineral resources. Then today I'd like to talk about REE. Then I don't know that today's the participant is student, staff, etc. I'm not sure, but my first question, do you like REE? I hope you would say yes. So then my answer also yes. Therefore, I'm interested in the geology for resource, geochemistry to understand the ore genesis. And but today I don't talk about one of my major is geoanalytical development of geoanalytical technique. So geoanalysis of the RE, I'm very interested. Then, first of all, so I think you know the RE, but I'd like to give you some overviews. Then we focus on the RE, but what is the RE? The RE is one of the rare metals, so-called rare metals. So in Japan, we use rare metal, but in Europe or US, they often use critical metals. Then if direct meaning from the rare metals, not seen or found very often, that's the meaning of rare. and metals are hard, usually shiny substance. So their metal must be a shiny substance which cannot be seen or found very often in the earth. But it's not. Not only direct meaning, the rare metals or critical metals include various meanings. Such as, this is the scarcity, that's one of direct meaning. So like PGM, indium, gallium, tantalum, these are very scarce in the earth, and really if scarce, we call rare metals. Or there are a lot, but limited at near subsurface. RE can be categorized in this section. So next slide, I'll show you how abundant, but honestly, there are a lot around the subsurface zone, but very limited. The third criteria is uneven distributed and unstable supply. RE can be included in this category also. So we have in the average cluster abundance is not so rare, but unevenly distributed or very unstable supply due to some political situation. Then last one, so including titanium, silicon, and magnesium, so technically or economically difficult to use. So one of, if the metals fulfill the requirement of one of these, can be called rare metals. So RE is enough to be called as rare metals. Then in Europe, we use critical metals. So rare metal, critical metal, somehow same meaning, same words. Then this slide shows the cluster abundance. The most abundant element in the earth is oxygen, followed by silicon, aluminum, blah, 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 blah. Then the highlighted part is REE. So the most abundant RE is cerium here. So ranking is 25. So not so rare. Then yttrium, lanthanum, neodymium, scandium, blah, blah, blah. Continue. Then if really rare, that's like gold or platinum. So the ranking is around 70 or around 70 or 75. So these are really rare. So relatively abundant, but we call their earth element. So these are not there based on the cluster abundance. Then if we see the visually, so the elements associated with rock-forming elements, these are really abundant. So like oxygen, silicon, aluminum, magnesium, iron, manganese, titanium, these are very abundant. Then the rare earth element is situated here, so middle range. So the similar abundance is tin or lead, tungsten. So those are the almost same level of the abundance. Then while those gold and the platinum group elements really rare. This slide shows the criticality of the criticality matrix. So considering the economic importance and the supply risk, the RE situated here really high supply risk commodity, and the economic importance almost average on average. But due to this supply risk, so if supply stopped, many of the people suffered from the problem. So we need to find and explore REE continuously. This is another matrix, almost similar. Then, especially, so in the first opening remarks, so the clean energy, green technology is important. Then to use for those green energy, green technology, that these red color, neodymium, dysprosium, terbium, europium, yttrium, these are all REEs, so very important for clean energy. And lithium, tellurium are another element included, but so these are very important for clean energy technology and supply risk. So for the resource security, we need to continue. You can understand from this matrix also. Then, not only RE, so if we see the statistical data, so what is really critical? Even using this table, the most critical one, based on the occupation by top 3 countries, the ratio is quite high, 96%. Then the top producing country is China, and for RE, so more than 80% is produced from China. Then followed by Australia and USA, but only 8% and 3% respectively. So the top 3 countries occupied 96% of the producing, top 3 countries producing the 96% of the ore. So very unevenly supplied. So that's one of the reasons for the top critical metals. Then probably my next question is, do you have rare earth elements? The answer may be yes. So now even this webinar through the PC, so we need RE in our gadget. Then so all of us use RE in some ways. Then this is a periodic table, and RE just to confirm. So where is RE? So scandium, yttrium plus lantanoid. So these 3 elements are called RE. Then among lantanoid, we have 15 elements. Then only promethium, this is not present in natural system, so we usually do not include. Then we use RE for the many high technology or green technology tools. So like automobile catalyst, we use cerium, phosphate, europium, yttrium, and this is very important to produce nickel hybrid battery. We use lanthanum and cerium, and permanent magnet for the strong motors. We need neodymium and dysprosium, and the magnet refrigeration, the gadolinium, etc., etc. So for those very important parts, it's actually made of REE. So if we are lack of these elements, these commodity, we cannot make we cannot sustain any green technology. So these are the examples. So engine, iPhone, electric vehicle, wind power generation, hard disk drive, we need rare earth elements. Then this is not so new data, but in 2010, early demand in the world, permanent magnet is the top share. And in Japan, the polishing, these are all include all RE. So as I explained, RE has various elements. So it depends on the elements that target different. But for polishing, we usually use cerium. Permanent magnet, neodymium, and dysprosium are main elements to be used. Then this is the unit mass of RE. So to produce hybrid, let's say that to produce hybrid vehicle, we need roughly 0.25 to 1.25 kilogram of rare earth element per unit. So anyway, we need many RE, so very concentrated, the small amount, but maybe for mobile phone, each has each phone. So the one unit is using very small amount, but multiply to the to cover the world. So 6 billion or something multiply, so quite big number. Then probably even in Indonesia, they try to find new resource of the REE, but the price is unstable and we don't say it's very high. So that's that people make hesitated to start new mining. So if some really critical situation occurred, these sudden jump up of the price happen, but not to last for the long, then again go back to the lower price. I think this is very high risk for the mining company to find new REE mines. And this is just repeated. So at least RE fulfills these items. So not scarce as I mentioned, but limited at the near subsurface. That's true. And unstable supply and technically or economically difficult to use. So RE is really included in rare metals. Then unevenly distributed, but so where is REE in the world? So this is the distribution map of RE deposit as of 2016. Most, if they are really roughly classified into two types. So first one is carbonatite types. These are rich in light rare earth elements. So I forgot to mention about what is light and what is heavy rare earth elements, but among lanthanoid, relatively smaller atomic number RE we call light rare earth element, and slightly relatively higher atomic number that we call heavy rare earth element. Then I need to emphasize we need heavy rare earth element. So the relatively bigger number of atomic number of lanthanoid we need to produce permanent magnet or for green technology. Then ion adsorption type of deposit is really important, but the observed ion adsorption type of deposit is very rare, mostly concentrated in the southern part of China. Some red star, the symbol, this shows the ion adsorption type, but distributed in South America and African countries, but mostly concentrated in southern China. Then the other carbonatite, sometimes very big deposit and related to magmatic power alkaline rock associated RE deposit are widely distributed. So if we see this distribution, the RE can looks widely distributed and looks less security. Then if we see the supply of RE, so this is as of 2014. So this is production, this is reserve. Then this is the current production, that more than 80% is from China, followed by Russia, Australia, US, India. But if we see the reserve, so as we can see, so production 110 kiloton, but in total reserve, the 130 million ton. So the 3 magnitude different. So if we see only this one, we see only reserve, not so critical, and we can the share by China can be reduced from 86% to 42%, so more various. So the other countries become larger. So for the supply risk looks low, but the distribution of the reserve and the production is not harmonious. So of course, there should be the reason to be like this. Then, this is visually shown use the USGS data. So in 1990 until 2000, the USA or other country also produced the REE, but after 2000 up to now, the mostly occupied by China. But that means a very risky supply. So if China control the price or the amount of trading, the price is can be suddenly high. Then another situation, the imports and exports balance is not so good. So for China, to export a lot and import some. Then like I put sorry, but Japan imports a lot of RE and exports as like secondary recovered materials we might bit export, but mostly in raw material we import everything. So this unbalance is often likely to happen for the many metals, but it's very remarkable. Then again, we are early again, so you can see China produced predominantly. This is a different year data, but the trend is the same. And the reserve, the China lower, but Russia bigger, and the US bigger. So if the concordant with early or reserve, if production follow these ratio, maybe supply risk is not so high, but the China predominantly supply early in the world. So we should change the structure of supply chain. Then, of course, there is a reason. So there are mainly two types of RE bearing deposit. First one, RE or from igneous rock. And second one is weathered rock, so-called ion adsorption type. So this includes still Japanese word, but I prepared a similar but different slide, so you don't need to see in detail. But in RE in igneous rock, very rough explanation, but RE is in refractory minerals and often associated with radioactive elements. So we have a lot, but very difficult to treat, or we need cost, or we need to manage, especially radioactive elements after we make a concentrate. However, if we use weathered rock type, so this type is very like soft materials, then don't have this problem, not included in refractory mineral or not associated with radioactive elements, so very safe or easy treatment. Then moreover, as I mentioned, so heavy rare earth elements very important for green technology, but in this type, the heavy rare earth elements relatively enriched. So more valuable rare earth element is included in only this type. So combined with easier easier operation, easier separation of RE from other waste, and include more variable elements. So these two factors enable China to produce rare earth element a lot. Then, so far, only southern China has a big ion adsorption type of RE. The ion adsorption type of RE deposit exists only in southern China in large scale. So that's why these results comes. Then this is a mineral resource for neodymium and dysprosium. So these two REs are used for the permanent magnet. So very strong magnet used for the like motor of the electric vehicle or wind power generation materials. Then in total production of RE is like this, but from ion adsorption clay, only these parts are produced. But if we see in detail from ion adsorption type or the most of the heavy rare earth element and important dysprosium neodymium is included. While we cannot see the dysprosium from bastonesite, so the bastonesite is representative minerals produced from igneous rock. Then these bastonesite or igneous origin RE ores are very rich in lighter REE, but partly neodymium, yes, and unfortunately contain uranium or thorium, so radioactive. Then abundant all over the world. So if we see the distribution map of RE in the world, we can see this type of deposit mostly evenly distributed. However, ion adsorption ore quite enriched in heavy rare earth element, especially dysprosium. So very good variable, and luckily no uranium and thorium, but unfortunately scarce and very limited based on the distribution. Then so far only distributed in China. So that's the reason for the unbalanced supply. Then just very use easy word. So for igneous rock, RE from igneous rock is very large quantity but low quality. This is a typical ore, and rich in light rare earth element. So some contains 3 to 7% very high content, but totally depleted in heavy rare earth element. And very unfortunately, thorium and uranium radioactive elements are enriched also. The ion adsorption type deposit, we can say high quality but low quantity, and mostly gathered in southern China. Then recently, the mechanism for the formation of ion adsorption type deposit is somehow clarified. So in tropical area, including maybe Indonesia, then the original rock weathered, and mostly parent granite weathered and weakly weathered granite, and some soil part produced due to the weathering. Then RE in parent granite and released from the host minerals and trapped, enriched in the clay zone. Then if the pH or the development of the clay minerals is adequate, the most of the RE can be concentrated at some zone. Then can be ion adsorption type ore. But we, including my group, we try to investigate many areas in Southeast Asia, but unfortunately, we could not find any good ion adsorption type deposit relevant to southern China. We cannot find. So, but the condition, geochemical condition is not special condition. So, still we wonder why only in southern China. And I have a collaborator in China, but very difficult to access the area they produce RE. So for foreigners, very difficult to visit. Then, schematically, so the from decomposed mineral RE released and trapped somewhere around these zones by clay minerals. But that's very simple mechanism to be a ion adsorption type RE deposit. Then this is just a summary. So REs are from igneous rock, large quantity but low quality, and worldwide distributed. However, ion adsorption type distributed only in China, small quantity but high quality. Then if we see a bit of detail about RE deposit type, igneous deposit include carbonatite, alkaline rock related, and hydrothermal deposit. Then among them, some alkaline rock related igneous deposit can produce heavy rare earth element, more variable REEs. In contrast, weathered type deposit, laterite deposit or ion adsorption type deposit or even placer deposit may be included here. Then only ion adsorption type deposit can produce variable heavy rare earth element. Then I talk a bit about placer deposit because in Southeast Asia, the tin belt is widely distributed. So one of the high potential area of placer type RE deposit. So I'd like to talk about it, but major RE is only lighter rare earth elements. So again, high quantity, large quantity, but maybe not so highly qualified. This is the size and grade of RE deposit, and the carbonatite. So the igneous type is usually very big and high grade, and ion adsorption type, so only these three, or very tiny, invisible. So only these small amount support world supply of heavy rare earth element. So only these. So the other mostly lighter rare earth element and igneous type. So this is really unbalanced. Then I include my representation title as geochemistry, so I put this one, but maybe I cannot consume many time for this one. But when we research about any ore deposit, the RE is often used for the geochemical tool. Then there is a reason. Then the RE is very sensitive to the redox condition. So if we trace this rare earth element, that we can know the formation environment of the deposit. Then the lanthanoid includes these elements, and these are situated in the same position in periodic table, so they should behave as the same, but they each has each atomic number, so the presence is different. Then this is called Otto-Harkins law. So element with even number is more abundant than that with odd number. So that's why we can see like zigzag patterns. Then if normalized with chondrite like this, we can get a very smooth pattern. Then we can evaluate using layers pattern. So we often use layers pattern, that is raw material was normalized by chondrite, then becomes smooth line. Then if this is if steep, rich in light layers element, and if like flat or opposite trend, the heavy layers element enriched. Then if we compare these ones, so Bayou Obo and Mountain Pass, these are the igneous type, and as you can see, very steep, very enriched in the light layers element. But if we see the Romnan, this is a representative from the ion adsorption type, and this has very relatively flat or rather enriched in heavy layers element part. So our target is to get these layers pattern. But very unfortunately that we could not, some area in Southeast Asia, the flat pattern, but very rarely tiny amount. Then in case of Lonnan China, the total RE plus yttrium, the content is 500 to 2000 ppm as oxide. Then this concentration is not high actually, but the ratio of lighter LRE, light layers element, and to the heavy layers element is lower than 1, so really enriched in this part. Compare with this one, if this one maybe 100 or 1000 is the ratio of light layers element to heavy layers element. These lists are the typical RE bearing minerals. Yeah, silicate, halide, carbonates, borates, many various type of minerals are included. Then this is just a repeat, so just skip. Then, so when we explore or if we want to start business on RE, we need to consider quantity and quality. So RE bearing mineral from igneous deposit, quantity is large, but quality is very poor. Then from weathered deposit, probably opposite. Which do you prefer? So you take the big amount, so small benefit, but accumulate such a small benefit, then get a big benefit, or really high quality one we find and get bigger profit. First, if we start early business, maybe we should select. Then in addition, these two are very important, white radish and durian. Of course, not accumulated, RE is not accumulated in white radish, but the idea of byproduct. So many commodities, like very limited commodity can be a main target. And like rare element, those are usually byproduct. But to produce byproduct, we need main product. So if we want to, if really we need like the leaf of white radish, but we cannot grow only leaf. Of course, roots, this main part should be grown. Otherwise, we cannot get nice leaf. So so RE is just byproduct, or only ion adsorption type can be main, but due to the low quality from the igneous deposit, very difficult to be a main. So RE is here. So so far, iron is the main, then RE can be byproduct in this example. So the other example, like if we produce
Recording stopped. Recording in progress.
produce a copper, then we can get cobalt, molybdenum, PGM, etc., etc. So those associated elements are just byproduct. Then another one for durian. Yeah, I love durian. So now I miss durian a lot. So, but that we use on the inside. The other outside hard shell part, I don't know how to recycle or reuse, but probably waste. So in case of the igneous deposit, these igneous type deposit for RE, this can be like a radioactive element. So when we get main fruits, we need to consider about the waste. So to produce RE from igneous rock type, we need to have a technology to manage radioactive elements. So this is a very big issue of the environmental impact. Then from now, I'd like to move a bit case study. Still, I hope I have some minutes. But early related research, I mainly conducted the ion adsorption type deposit around the Malay Peninsula to Bangka Island, and also nickel laterite in Philippines. So nickel laterite is developed in Indonesia, so both information may be useful for you. Then first one, we investigated the ion adsorption type deposit around Southeast Asia from Thailand, southern Thailand and Bangka Island, Indonesia. Then again, just to repeat it, but the ion adsorption type high quality but small quantity deposit is really located around southern China. Then in general, the grade is very low, only 0.05 to 0.2%. However, rich in heavy rare elements of dysprosium or other relatively big, large atomic number elements. So high quality. Then no radioactive elements, easily extract. This is just repeated skip. And those type of deposit, of course, we need. This is wizard, so we need host rock. Then in general, the host rock is a S-type or ilmenite series granite. That's the original one. So these contains higher REE when it crystallized. Then these type deposit, this type tin tungsten deposit are widely distributed around Southeast Asia. So these red color can be potential area, including southern China. Then this is a granite type summary. So S type is sedimentary material origin. So sedimentary rock are melted and form the magma, and these can accommodate much higher REE. Then we have two different classification methods. So if we say ilmenite series, that these condition is reduced and often associated with the tin tungsten, gold, and rare element, and poor in sulfide. So this is typical. So usually if we need to find like porphyry copper deposit, we prefer to find magnetite series relatively oxidized magma to get copper, molybdenum, gold, and etc. Then luckily the Southeast Asia, the tin belt and S-type related granite is widely distributed. So it should be a very good target. Then this is the fractionation, so not so important here. Then if fractionated, so among S-type deposit, but highly fractionated, the more higher concentration of heavy rare earth element in granite. So because rare earth element is relatively incompatible to the magma, so residual magma can accommodate more rare earth elements than resulting like this. So as increase in SiO2, so the going to the residual, the higher heavy rare earth element in original rock. Then experience tropical climate, the precipitate around 2,000 to 5,000 millimeter per year. Then primary alteration, weathering or hydrothermally occurred. Then finally, RE can be trapped in clay minerals by ion exchange interaction. So that's a scenario. So we know the scenario. So, and we can know the suitable zone. But so far, very difficult to find. Still, we wonder. Then, this is, sorry, I skipped this one. Then, geological background, southeastern Tin Belt, where we studied. So along the Thailand, recently we expand to the Myanmar, but Myanmar, Thailand, and Malaysia, and up to Bangka Island. Then good exposure of S-type or ilmenite series. Then well weathered. Then if we look at southern Thailand, and we visited several closed tin mine, and we can find clay vein in hydrothermal altered granite or the weathered soil. Then also in Bangka Island, we collected several weathered crust, what we call weathered crust. So horizon A is the soil, then horizon B well weathered, and horizon C partly parent rock remained, but well developed weathered granite we can observe. Then we collected many samples and we analyzed early contents and etc. Then this is the result. So the total rare element actually only up to 800. So compared to the southern China, it's very low. Even the fresh rock, even weathered rock. Then but some of the clay vein contains such a high content. So normal weathering plus hydrothermal alteration cause these extremely high early contents portion. Then this is against zirconium. So zirconium in mostly zirconium from zircon. So zircon is a very refractory materials. So if zircon still contain many REE, we cannot get easily. So similar to the igneous rock type RE deposit, that we need much, let's say, higher temperature for the metallurgic way. So not so preferable. But unfortunately, along southeast Tin Belt from Malay Peninsula to Bangka Island, still many are included in zircon. So still in the form of refractory. So that's a problem. But only as I explained, the higher contents can be observed from clay veins. So those clay veins, if we look at the clay veins, so if we extract only clay vein, up to 1,300 ppm. So this is relevant to the southern China. So in southern China, the all weathered granite being like this. So we wonder that only weathering or hydrothermal alteration also combined with the normal weathering to produce ion adsorption type deposit. But at least in this area, from Malay Peninsula to Bangka Island, we need the help of hydrothermal alteration. Then we roughly understand what is the presence form of the REE. Then we clarify the RE contents of the Southern Thailand, Bangka Island, and those are not enough concentration, but clay vein after hydrothermal alteration can show the good quality with relatively higher heavy rare earth element contents. So this is one good example. So better to find the area weathering plus hydrothermal alteration occurred. Then how are they enriched? But I did not explain in detail, but very weakly combined with the surface of clay minerals, so very easily extracted. So this is a similar characteristic with the ion adsorption type RE ore from southern China. So these clay veins is almost the same mechanism with southern China RE ore. Then, again, this is a mechanism shown by Sanematsu and Watanabe, 2016. Very simple. The RE in original rock decomposed by weathering, then released RE can be trapped by the, except for cerium. Cerium is very sensitive to the oxidation, so they are just removed. But the other element, except for cerium, can be trapped by the clay minerals. Then for clay minerals, we prefer illite or kaolinite, monmorillonite because to interact between RE ions in aqueous phase, the surface charge is very important. So RE most probably positively charged in aqueous phase. So aqueous phase while weathering. So if in the soil side, if we have illite or kaolinite or monmorillonite to have negatively charged surface clay minerals at pH 4.5 to 7, this is corresponding to the soil pH. So if this condition is attained, the easier to accumulate. So if too much weathered and rich in hematite or gaysite or gibbsite, so too much weathering occurred, proceed, maybe the RE just passing through, so no accumulation. Then sequential extraction is to understand what is the presence form, but maybe it's, I skip. Then maybe already time is come. Still I have time, or should we stop here?
Okay, I'm sorry, Henry. We actually ran out of time because your time is until 10. So maybe you could sum up your talk, please.
Okay. So if I have my next opportunity, maybe I can talk on the rare earth element in nickel lighter deposit. So my message, so this time I show only the positive side of the RE industry development, but I don't know today any person participate from the industrial side, but the motivation of opening new RE mine is not so high, I guess, because this is statistic data and valuable production by commodity. So still main product, iron, copper, gold is high value. Then followed by manganese, zinc, RE are very less valuable than base metals and precious metals. Maybe this will not strongly encourage the industrial person to start RE mine, but importance is definitely important. So we need RE. So somehow we need to change this order. And beyond the option type, yes, easy treatment. Easy, I said easy, but currently causing many problem of the environmental impact. So this is from the website. So maybe too much emphasis on the negative part, but definitely strong damage. So we need to consider about environmental impact, and we start new development. Yeah, thank you for your kind attention and invitation today. Terima kasih.
Yeah, thank you very much, Yanisa Sensei, for the very informative and fruitful talks. Maybe if you would like to ask question, please raise your virtual hands. Or
Bunisa?
Yeah, please, Ian.
Okay.
Yeah.
Okay, thank you, Bunisa. Excellent presentation of your topics, Prof. Kotaro. I want to ask you a simple question, about green energy for the future, Do you believe for the future, fossil energy will change to battery or electricity, and our world become to use green energy? Do you believe that? So, if you believe it, so how to prepare that? And I am talking about all country, And then I know you are a geochemistry, So I want your answer is in your knowledge. Please, Prof. Kotaro, thank you.
Okay, yeah, it's a very, very difficult question. But almost all we agree we need some change on the industrial structures. Then, if the environmental issue first, maybe we need to replace. Then, to replace, we need new materials, and to make new materials, we need maybe new commodities to support. So from mining or geology, geochemistry side, we need, if there's some technology develop, and let's say if we need really electric vehicle, so what is the electricity source? Then we use lithium battery or nickel bearing battery. Then depend on that, we need to find nickel source and lithium source at least. But for this, maybe we can contribute, and maybe those are possible. And as often the case in Japan, so like if car industry change from using fossil fuel to the battery, the many lose like job or something, but replaced. So in shorter range, maybe very big impact on many industry, including mining, but for the longer span forecast, maybe okay. So for the next generation, we should change, and maybe we should be ready for that change, I think.
Okay, thank you. So maybe we need a big effort, to prepare that.
Yeah, so we need effort from the each expertise area.
Yeah.
At least
Chat box. So we have several questions from Professor Eldram, our colleagues in the Faculty of Geological Engineering. The first question is, what was happened in 2011 that causing the price of REE to be very high? Should I read all of the questions, Sensei?
So that question is in chat box?
Yes, it is in chat box.
Okay.
The first one is what happened in 2011, which caused the price of REE
Okay.
was very high.
So 2011, the China and Japan has a conflict around the channel. So maybe you also facing a similar problem somehow, but then they stopped producing, exporting REE. So the price is extremely high. So that's an unusual situation. But then we realize the China controls the RE and the RE controls the green technology. So we need RE. Then that's one can be a motivation for us to find alternative source. So good turning point for us. But for the industrial side, should not expect such a high price. So if we start producing RE from other type deposit, of course, price is going down. So not so easy, I think.
Okay, so we are going to move to the second question, I guess. Maybe you can see it according to the distribution map of REE in the world that you have showed us already. In Indonesia, there are REE, but in form of placer deposit. In your point of view, is it true that Indonesia's REE potential just a placer deposits?
Yes, so today I did not show the slide, but so placer deposit and ion adsorption type deposit origin is the same. Then distribution of RE is different. So if RE incorporates into refractory mineral like zircon or some apatite or something, xenotime or phosphate, that's resistant to the weathering, so remained. Then those can be from placer type deposit. And if silicate or easily decomposed mineral host the RE, those are released and accumulated in ion adsorption type. So if only refractory type, so placer deposit, then probably you may have a problem on the radioactive elements. So not so easy. So similar to the igneous rock type RE ore, you have the problem, both advantage and disadvantage. So probably large quantity you can get from placer deposit, but quality is not so high. So you need to select.
Maybe the next question. I am going to read only two last questions because of the time. So maybe Sensei, you could answer the question on the chat box. Or if you are not bothered.
Okay.
Okay. So I am going to read the third question. So it is from Mr. Birian Sagala. So he asked about why China producing RE so high compared to other countries? Is China geologically rich with RE deposits or because of China has advanced technology?
So far, for China, so they have inland, like Inner Mongolia area, they have a big carbonatite, buying over. So recently not a carbonatite deposit, but a big deposit for producing light rare elements. And also they have a southern coast ion adsorption type. So they don't have a special technique, special advanced technology to produce, but most of their share is derived from the southern part of China, from ion adsorption type. That's geologically not so unique. Based on the documentation, just S-type and bit fractionated, but the mineral composition in weathered granite is like smectite or very typical minerals only. So nothing unique, but probably the original grant is very huge and really, how to say, really accumulated. But that's the only difference. So even tectonics are similar to the Southeast Asia. So just to continue. So still we wonder. But so far, nothing special. But the original volume is very large. So that's one difference compared with other region in S-type granite.
So, thank you very much, Sensei, for your answers. Maybe I am going to sum up all of the questions in the chat box. So maybe if you would like to ask the question via the chat, you can answer it without confusing by a lot of chat info in the future. Okay, so thank you very much once again, Sensei, for your very informative and fruitful talks. And thank you very much for the question and answer. We have quite active participants with a lot of questions. So maybe if you have additional question, you can write it in the chat box and maybe you can answer it. Right?
Okay.
Okay, so thank you very much. And once again, I'm going to close the first talk in this session. Okay. And thank you very much, Sensei. Okay, so ladies and gentlemen, we come to the end part of the first presentation. We would like to thank you once again for our presenter, our invited speakers here. Hopefully this presentation will be beneficial for all of us. Thank you. And then we are going to move to the second presenter. Here. Bu Kamala?
Yes, Mrs. Nishan.
Can I give it back to you
Thank you
first?
so much.
Oh, I'm sorry.
Before we start to second speaker, maybe we will give some appreciation to our speaker, Associate Professor Kotaro Yonezu, for the great explanation. And as our appreciation, we will give a certificate that will be given by Learning, Student Affairs, and Alumni Manager of Faculty of Geological Engineering, Universitas Padjadjaran, Mr. Agus Didit Haryanto. Please welcome. For Mr. Agus Didit, maybe the microphone is turned off.
Pak Didit, mungkin headsetnya dilepas saja, Pak.
Okay. Bu Kamala, you hear my voice?
Yes.
Okay.
Please.
Okay. Konnichiwa, Professor Yonezu. Welcome back to my faculty.
Yes.
Okay, Professor Yone. On behalf of my faculty of Geology, Universitas Padjadjaran, I will give you a certificate for appreciate my webinar international fourth series today. Please, Bu Kamala, can you share the A certificate for Professor Yonezu?
It's already appeared.
Okay. Okay. Professor Yone, Professor Mega can join this time because she has a lot of to do. So again, for your contribution with our seminar, I give your certificate. So thank you very much, Professor Yone. Okay, konnichiwa. See you later. Yeah, I hope.
See you in Bandung.
Okay, thank you. Thank you, Bu Kamala.
Thank you so much for Mr. Agustidit and also Associate Professor Kotaro Yunezu for the wonderful explanation. And for all the participants and also committee, please turn on your camera because we will take a photo together. So are you ready? Give a big smile. 1, 2, 3. Once more. 1, 2, 3. All right. Thank you very much. And for all of the participants here, I would like to inform you that this webinar also streaming on YouTube, and you can watch later for the presentation of our speaker on YouTube, Fakultas Teknik Geologi. And before we continue to the next speaker, I also would like to say thank you to our sponsor for 60 seconds, this Natalis of Faculty of Geological Engineering, PT Kaya Tirta Mandiri, Contractor, General Trading and Supplier, Adaro Mining, PT Marwai Coal, PT Raflindo Pratama, Drilling Hydrogeological and Civil Construction, PT Timah, and the last is Pama Indo Mining. All right, everyone, please welcome to our moderator, Mrs. Nisa Nurul Ilmi, to continue our webinar.
Okay, thank you very much, Ms. Kamala, for your introduction. And we are going to move to our second speaker. I would like to welcome, ladies and gentlemen, may I have your attention? I am going to welcome to our honorable invited speaker, Mr. Zulfikar Yurnaidi. First of all, I would like to read our speaker summary. Yeah. So, Dr. Zulfikar Yurnaidi is a senior officer of Sustainable Energy, Renewable Energy, and Energy Efficiency, or REE, Department of Asian Center for Energy, or it is abbreviated by ACE. He is also a senior researcher analyst of Asian Climate Change and Energy Project, or it usually abbreviated by ACCEPT. And in those roles, Dr. Zulfikar conducts research and cooperation activities in the field of renewable energy, energy efficiency, and climate change. Currently, he is a team leader of the 7th Asian Energy Outlook, leading the development of the flagship publication of ACE. He holds a doctoral degree from the Department of Energy Studies, Aju University, South Korea. And prior to ACE, he was a researcher in the Green Technology Center, GTC, South Korea, focusing on green technology cooperation with partner countries, such as on waste to energy, climate smart agriculture, water monitoring system, and AI-based disaster response in Indonesia and Bhutan. And prior to that, he was a postdoctoral researcher and also a lecturer in Aju University, South Korea, working in energy modeling and energy economics. Okay, to Dr. Zulfikar, please welcome to give your talk.
Yes, thank you very much and good day, everyone. Good morning, still morning, I think, in here. Thank you very much for the opportunity. Again, first of all, I would like to say congratulations as well for the anniversary of the Faculty of Geology Engineering of Pajajaran University. My name is Zulfikar, as introduced kindly by our moderator, Ms. Nisa. I am currently working in the ASEAN Center for Energy, especially as the senior officer of renewable energy and energy efficiency. We also call it the REE department. So just an introduction. So my background was not a geological engineer. I was from electrical engineering, then moving to energy system, especially in the modeling but also focusing on the renewable energy and energy efficiency, and also energy climate nexus. So I think the presentation that I'm going to share today is probably like a little bit different from what you might expect from the department. But I think it's it can be quite interesting as well for the participants from the faculty and students of your department to hear like beyond geological and engineering stuff. So I'm going to present a little bit about the green energy future, especially in the region, in the Southeast Asia. So let me try to share my screen. So I believe you are looking at my screen right now. And taking the topic of the international webinar, Green Energy for the Future, especially focusing on the ASEAN, Southeast Asia. And I think I would like to start with introducing our institutions because some of you might not know it yet. So we are ASEAN Center for Energy. We call it ACE, not the ACE Electronics, of course, for those of you in Indonesia. And we are actually representing the ASEAN member states' interests in the energy sector. So we are under the ASEAN, although we are not located in the ASEAN Secretariat. Our office is basically in the electricity directorate of the Ministry of Energy and Mineral Resources in Indonesia, because they host our institutions. And we basically have three roles in supporting the ASEAN member states. The first is as a think tank, in which we conduct studies related to energy in the region, mostly on the policy side, but also in the technology, although we are not too deep in that, and also provide policy recommendations. You may visit to our website, the aseanenergy.org, to find some of our latest studies. We also have a role as a catalyst, meaning we connect the member states to collaborate within region, but also with another country, our partners, we call it dialogue partners, and also international organizations. And we did that. We have this annual ASEAN Ministers of Energy meeting every year on September, and also like several sectoral meetings pertaining for renewable energy, energy efficiency, ASEAN power grid, and other sectors. But also we assist the ASEAN member states in having a meeting and joint project and programs with dialogue partners such as India, also the +3 countries, which is China, Korea, and Japan, US, Norway, and many other countries. And we also have a role as a knowledge hub. We try to collect data and also information related to energy in the region. And that includes the statistics, which we use to produce the ASEAN Energy Outlook, which is our flagship publication. We publish it like every 2 years, and in which we try to see the trend of energy system in the region, and also potential pathways of the scenarios of energy evolution in the region. We also produce what we call the news clipping, in which we gather the energy-related news in the region for every week and blast it as a mailing list. So if you are interested to find information about the energy in the region, you might visit our website, aseanenergy.org, and register in our mailing list. And beyond those three roles, we are basically tasked to implement the regional blueprints, energy blueprints, which is called the ASEAN Plan of Action for Energy Cooperation, or APAEC. Currently, we are in the 2016-2025 period, which is divided into 2 phases. The first phase is the first 5 years, 2016 to 2020. And then from this year, we started the second phase, 2021 to 2025. I would like also to introduce what is APAEC, because that is basically what guides the activity of ACE, but also guide the activity of the ASEAN member states in terms of energy cooperations. And in APAEC, we have the theme, which is the enhancing energy connectivity. and also market integration in ASEAN to achieve energy security, accessibility, affordability, and sustainability for all. So this security, accessibility, affordability, and sustainable, we call it here as the four pillar of energy cooperation in ASEAN. And you might know the issue of energy security, meaning that we have to secure our energy supply, meaning it should be available for the next mid and even long term. Accessibility, meaning that 100% people in the region have access to modern energy, including electricity and also clean cooking. Affordability is more close to the price, and sustainability is so that the energy usage in the region does not have a negative impact to the environment, which might harm the future generations in energy access as well. And specific for this phase 2, we have the sub-theme, which is called the Accelerating Energy Transition and Strengthening Energy Resilience through greater innovation and collaboration. So as can be seen here, we are more focused on the energy transition, moving from the traditional energy use into a more modern, cleaner, and sustainable energy use, including, of course, the sustainable, the renewable energy. So I think the topic of the webinar is very fit with our role and our activities in ACE, which is to promote also the green energy future. And within this blueprint, we have like 7 program areas, so 7 aspects of energy, which is quite comprehensive. So we do not only pushing renewable energy, for example. We do have it as the 5th program area, renewable energy. We also work on the improving the energy efficiency and also energy conservation, the 4th program area. But we also deal with the fossil fuels, including the clean coal technology, the coal power, and also the Trans-ASEAN gas pipeline, which is actually handled by the ASCOP, which is the Association for Oil and Gas Companies in the region. And also we deal with the electric utility, especially in the framework of our program area of ASEAN Power Grid, which the idea is they want to expand the regional multilateral electricity trading. So like trading electricity between ASEAN countries. With the latest update is the progressing work on the LTMS, which is the Laos, Thailand, Malaysia, and Singapore to trade electricity between Laos and Singapore going through Thailand and Malaysia. And also important in ASEAN Power Grid, the role is to promote cleaner and renewable energy integration. And other than that, we also have a regional energy policy and planning, which is more encompassing and dealing with the energy policy, energy climate nexus, etc. But as you may see here in the 7th program area, we also deal with nuclear energy. We know that there is no ASEAN countries currently utilizing nuclear energy. Philippines, they used to have a nuclear power plant, Bataan power plant. And I think within the last year and this year, there was a talk by their president to restart the project. And I think we heard also well in Indonesia, there are several talks of the nuclear energy as a potential energy mix in the future. But basically what we're doing now in nuclear is more on the capacity building to build the human resources for the use of nuclear for both science and power generation. So these are the UPHIVE, which is the national, the regional energy blueprints. And among all of the 7 program area, we have 2 targets. As you can see here in energy efficiency and conservation, we are targeting to reduce energy intensity. Energy intensity is a measurement of energy efficiency, which is a measure of energy use per GDP, meaning like how much energy you use for each dollar of your GDP in a country. So we want to reduce it by 32% by 2025 based on the 2005 level. Meanwhile, for the renewable energy, we target to increase the share of renewable energy up to 23% in primary energy supply but also to increase the share of installed capacity in electricity sector to 35%, also by 2025. And I just highlight that usually within program area, in that APIC document, we design several outcome-based strategies. We call it OBS. And then within OBS, we have several action plans, and which needs to be done by the ASEAN member states, supported by ACE and international organization and dialogue partners within the period until 2025. And I just selected for energy efficiency and renewable energy just to highlight a few items that we are doing here. For energy efficiency, for example, we had 5 OBS, 5 strategies ranging from standard and labeling, the first one. The second one, more on the participations of private financial institutions, so not only to improve the public-private partnership. And the last 3 is specific energy efficiency programs or strategies for each energy sector. First is the building. In the building, we usually mean about both residential and commercial. We also had strategies for transport system and also industry. So we try to be all-encompassing in this energy blueprints. And we have several activities, like for example, we are working on the product registration database to improve standard and labeling. We also have work with IEA, International Energy Agency, to pursue this sustainable energy efficiency building and also cooling roadmap, and also others. And for renewable energy, we have like 6 strategies ranging from the advancing RE pathways and policy. And into this, we are working with IRENA to develop the renewable energy outlook, slated to be published soon. And high-level policy dialogue on renewable energy with our collaboration with IRENA, IEA, and also other institutions. Improve the R&D, research and development in renewable energy, but also the financing scheme, which we know can be a huge bottleneck for the renewable energy development in the region. But also we have like specific one on the biofuel and bioenergy, noting that there are a lot of resources currently in the region, especially in Indonesia and Malaysia, on the biofuel, but also bioenergy such as waste in the big cities. And we also have specific strategies on the energy information and training center, because we noted that with the increase of renewable energy penetration in the future from solar and wind, these human resources would be very, very important for installation, maintenance, operation, etc. So those are just some examples of key action plans, strategies in ASEAN level, in the regional level, and which also in line with the national policies and also paths towards this energy transition, including green energy. Another thing that I would like to introduce is the ASEAN Energy Outlook, which is the flagship publication of ACE. And this is answering directly the APIC. So we try to incorporate all the program areas of APIC, ranging from the ASEAN Power Grid, energy efficiency, renewable energy, but also hopefully in the nuclear energy. So we are, as mentioned, I'm currently leading the development of the 7th ASEAN Energy Outlook, or AO7, and we are currently discussing whether we want to introduce nuclear or not, and how we want to limit that. So those kind of, all of this program area will be the spirit of the development of ASEAN Energy Outlook. Additional note, the 7th ASEAN Energy Outlook, AO7, is to be launched next year in the ASEAN Ministers of Energy meeting, or AMEM, the 40th AMEM. It should be in the Cambodia. So the chair of this AMEM is always changing every year following the alphabetical order. This year is Brunei, so next year we're going to Cambodia to hold this AMEM meeting. Although from the latest discussion, it might be in virtual setting still due to COVID-19. So basically, this ASEAN Energy Outlook, or AEO, we try to complement APIC. It derives the strategy, but we want to show how to do that, especially in the creation of pathways to achieve the regional target, the RE and the energy intensity reduction target. And in program area number 6, we have action plan 1.2, which is to publish regular regional energy outlook, the AEO, and also related strategic reports on the thematic issue. So to explain about the AEO and also to share some results from the latest AEO, AO6, which was published next year in the AMEM 38th. And in Vietnam. And so we, as mentioned before, the AEO, we tried to see the pathway of energy mix in the region. And we have the primary energy supply and also the final energy consumption. And so we have like several scenarios here. So we have the baseline scenario, the ATS scenario, the APS scenario, and the STG. Sorry. Yeah, apologize. There's some domestic issue. So yeah, let me continue. So basically what we have is like 4 scenarios. The baseline is like business as usual, reference scenario, but we also the ATS, which is the national target scenario. And we input the country-specific target there, which is from renewable energy, energy efficiency, and also energy access, the electricity target, and also the energy-related NDC. And we also have the APS, which is the APIC or the regional target scenario. And because there is a gap between the ATS and the APS, and we designed this APS scenario based on the country suggestions, renewable energy, power plant potentials, upscaling the current renewable energy and energy efficiency efforts, and others. Due to that, we have these results. And basically what we are seeing here is that the energy use, both in the primary but also in the final energy, is going to be increasing a lot. In the final energy consumption, in the baseline scenario, it will be increased by 2.46 times from 2005 to 2040. Similarly, in the primary energy supply, it will be increasing by around 2.5 times. But when we apply the scenarios, both in the energy efficiency and also renewable energy, we can reduce the energy needs because when we improve energy efficiency, we only need less energy with the same level of GDP. So that's why we see here, especially in 2040, compared to the baseline, the total primary energy use will be reduced from baseline to the ATS, and reduce further when we pursue stringent, stronger energy policies in the APS or the regional target scenario. So this is how we work in ASEAN on seeing how the regional policies, the energy mix in the region, and yeah, I just want to focus a little bit on the renewable energy because the topic is on the green energy. So what we are looking here that from our historical data, 14% of renewable energy in primary energy supply. If we only consider the national target in the AO6, we thought that only 18% of renewable energy will be achieved in the primary energy supply. But then we introduced the APS, which forced 23% of renewable energy in TPS, which is the target of the regional, of the ASEAN regional target. So we achieved the number in the 2025, and we plot the same trend moving forward. We can reach at most 29% of renewable energy in primary energy supply by 2040. Of course, this should be noted. This is a result from our study last year. And for the installed capacity, we see that the region can reach up to 33%, even in the national target scenario. That's why we set the target of installed power capacity as 32%. And but if we have stronger policies, we probably can reach up to 48% of renewable energy installed power capacity in the electricity sector only. So like, as you know, renewable energy is not only in electricity generation, but we also use it in transportation sector, for example, as biofuel and, other sector as well, like industry, maybe through biomass, commercial also the same. Something like that. And in 2040, if we continue with the strong policies in the IPS scenario, we probably can reach 51% of renewable energy in the installed power capacity. I will update you a little bit more later on the real value that we have up to 2020. So in this AO6, we use 2017 as a baseline and project 2018 to 2040. And in summary, what I can say is that the energy demand is increasing and will always be increasing if we do not do much on the energy efficiency front. And as you know, our economic growth is the fastest in the world as a region. We had Indonesia, which is the part of the top 20 GDP in the world, and then to fuel both the population and energy growth, you need energy. And in primary energy, as I mentioned, it's increased 2.1 times in the primary and 2.3 times in the final energy. And it also require a lot of electricity as part of the energy. And we've seen here in the national target scenario, so not the baseline. In the baseline, it's even higher. The increase of installed capacity is around 2.6%. The fossil fuel, the renewable energy share is continue to increase from 26, as you can be seen here, to 36.8 potentially in 2040, and even higher in the APS scenario, around 50%. But still, the fossil-based generation, the coal, and especially and also like natural gas, will still be there in our energy mix. And since our model does not show something that is too ambitious, so we consult with countries, it kind of shows the reality in the ASEAN countries that we still need a fossil fuel generation at least for 20 years to come. And I hope you're still seeing my screen. And so I'm continuing, but fortunately this energy transition is actually already here, and potentially it can be very helpful. So in the left, we see the projected power capacity expansion. As we see here, the renewable energy will constitute most of the additional installation of electricity power generation in the future, especially in the APS. And we see that kind of trend is also happening with countries like even including Indonesia stated that they will not accept new proposal in coal power plant, for example. They're still ongoing, which is already in the pipeline, but no new coal power plant. The same with other countries in the region. And it's very good. And we also noticed that from our study, the potential investment is quite high for the energy transition, of course, because it's still a lot more expensive. Not a lot, but in general, more expensive compared to some conventional energy, partly also because of subsidy and others. But we also noted that it can create a lot of co-benefits, such as creation of jobs in solar and wind. And as we see in here, we also try to see the impact in the emission, GHG emission, greenhouse gas emissions. And we see that from the baseline, if we move to the APS, have a stronger policy in RE, renewable energy and energy efficiency, and then moving into an even stronger one, the regional target, we see that most of decarbonization, which is reduction of carbon emission, coming from the three sectors, especially the industry, residential, and transportation, because those sectors will be those that use a lot of fossil fuels currently, electricity for generation, power, transport from the petroleum products, industry, both petroleum products, but also in the coal and oil, especially in petrochemical, in food beverage for boiler, but also in especially like chemical, petrochemical, steel, which still use coal for their furnace, for example. And why green energy? So I think I spent a bit too much for that, but I will try to accelerate moving forward. So why green energy? First is to energy security. So we are currently Indonesia, not Indonesia, ASEAN as a region currently is a net oil importer. We are still net coal and gas exporter, but without significant new discoveries, with the same level of demand, we are going to start to become net importer of gas from 2025 and coal from 2035. Of course, this is based on our baseline scenario, which will be different when we are looking at the other scenario. And the fossil fuel is quite volatile. And I think you've probably seen in the news the price of coal, the price of gas is increasing, rocketing because of this recovery from the COVID-19. The Europe countries, they rely on gas, but then Russia do not refill their gas sales, the future gas sales. China, they start to have this economic recovery, but then they do not have enough coal coming from their own country, but also from Australia and others. So they have an issue in terms of pricing. So this is very important to think about how we can manage this energy security in the region. And also sustainability concerns. We have two things here. First, on the left is the Sustainable Development Goals, or the SDGs. Especially the SDG 7, the affordable and clean energy, which had 5 targets, 1, 2, 3, and A and B, on the universal access to modern energy. This is usually quantified by electrification ratio and also clean cooking access, but also specific goals in terms of renewable energy and energy efficiency. And there is also, on the other hand, as you might aware as well, a lot of discussion on greenhouse gas emissions, how it impacting the climate change, and how the countries need to do something to solve those issues. And as can be seen in this graph, this is 2016 data, but it's still used widely to show that energy is actually the largest #1 contributor for the global greenhouse gas emission. In Indonesia, the forestry and land use is a bit higher, but generally in the ASEAN, also in the region and in the global, in the world, energy is the largest contributor for greenhouse gas emissions due to the large use of the fossil fuels. And yeah, I just want to note that this year we're going to have this COP26 postponed from last year due to COVID. And there are a lot of things currently going on in this front, including the net zero targets have been spring out from the countries, not only in European, but also in the region. The Singapore, they mentioned they will reach net zero in the second half of the century, so beyond 2060. Indonesia, as you know, previously the Ministry of Environment and Forestry had some studies targeting 2070 as the net zero target. And then in their official submission to the UNFCCC, their long-term strategies for emission reduction, net zero is in 2060. The Bapanas of Indonesia also have like several scenarios ranging from 2050, 60, 70 as the target of net zero. Net zero meaning that the emissions it's zero. So your emission and your reduction can be coming from the agriculture and land use in Indonesia is zero balanced. So and also we have a lot of huge potential. This is a study. We probably going to have the public version very soon. Currently, it's only for ASEAN member states only. But we had this presentation in one of our events showing that we have a huge solar sites, and also wind sites, which potentially generates 124 terawatt hours of electricity for solar and 27 terawatt hours for wind in the whole region. And this is already technical potential. So we excluded some areas that we cannot have a solar panel there, etc., and something like that. The cost has continuously fallen. This is a study from IRENA. It's kept falling from 2010 and even 2019-20. Almost every year we had news that the LCOE, levelized cost of energy for solar, for example, keep hitting new low record. Of course, some of these are coming from countries such as on the Middle East, you know, where they have like very strong solar and probably like cheaper in terms of equipments, etc. But also starting to happening in the region. In the region, the cost is still expensive, but continuously decreasing. That's another reason why we have to pursue the green energy. And as I mentioned before, I'd like to update the latest status for green energy in the electricity. This is based on our latest study, ASEAN Power Updates 2021, just published, I think, last month. And in 2020, we see that there are 285 gigawatts of power in the region. Almost 2/3 is in 3 countries, Indonesia, Vietnam, and Thailand. So Indonesia is the largest with 25% of installed power capacity, followed by Vietnam 24% and Thailand 17%. And still, currently, more than 80% is coal, gas, and hydro. The fossil fuel is still high, coal 30%, gas 30%, hydro is also huge at 20%, huge contributor to renewable energy. But what's interesting is the additional installed power capacity in 2020 compared to 2009 is among 22 gigawatt added capacity, about 80% is coming from renewable, especially from the hydropower here in the Laos and also solar power in Vietnam. So they added 12 gigawatt of power capacity in 2020. And similar number was also achieved in 2000. I mean, the last 2 years from 2019, 2021, they keep producing a lot of solar because they have a very strong feed-in tariff policy there. But this is a new trend, which is quite positive for the development of green energy in the region, which can be a very good lessons as well for countries such as Indonesia. And the top 10 ASEAN power project in 2020, we have still coal power plants in Indonesia as part of the fast track program, but we also have the solar power farm in Vietnam, 450, which is the largest solar farm currently in the region. And we also have floating solar currently becoming like the new trend of solar in the region. Malaysia, Thailand have their own large floating. Indonesia is currently building in Cirata 145 megawatt, which will be the largest in the region once it's finished and operating, targeting next year. So there are a lot of good progresses in the renewable energy. And moving forward until 2025, based on the power development plan, similar to our UPTL in Indonesia, more than 60% additional will be from renewables from our study. And it means we probably can reach 37.6 of renewable energy in installed power capacity in 2025. And as a reminder, it's higher than the regional target of 32%, and meaning that we are progressing in the right way, hopefully. And just a little bit of note that the renewable energy is progressing quite well amid the pandemic. A study from IEA showed that in the left side, the emissions is reduced in 2020, but increased again in 2021 due to the economic rebound. And if you see in the right-hand side, the electricity generations coming in the global level, so not only in the region level, coming from solar, wind, bio, hydro, which is renewable energy. Although for the fossil fuel, they decrease in 2020 when pandemic comes, and then increase again when we have this recovery. So if you can see here, coal, gas, nuclear start to producing electricity again. But renewable, they have the same consistent progress of acceleration of transition, moving from the fossil fuel to renewable energy. And this is just some updates. I'm going to the closing parts now. So the SDG 7 in the region, as you mentioned, electricity, we actually have very good progress in there. Around 100% will be reached by the SDG target year in 2030. And the challenge though is in the clean cooking. There are still more than 100 million people currently still use traditional biomass, the wood, and we have to find a way to shift that into cleaner cooking, using LPG, biomass, biogas, or even electric stoves. And we also noted that the RE and E has been increasing quite well, but still there are a lot of works need to be done, especially with the new increased notions of the net zero and others. A bit of reminder, the decarbonization potential is coming from power, transport, and industry, which can be difficult, especially in industry, but not impossible. I talk a lot about power, but a lot of whole stories coming from the transport, transition to electric vehicle and also biofuel, or even like hydrogen, fuel cell-based electric vehicle. And that's what, there are a lot of technologies coming, but I try to capture like some emerging technologies that might be important for you to think about. The first is the hydrogen. It's crucial for secondary energy. It can be transported easily. It's a gas. It can play a role similar to electricity as a secondary energy. So you transform, usually currently it's coming from natural gas or a biomass converted to hydrogen. But in the future, we can have what we call the green hydrogen, generating hydrogen from the solar, from the wind, and that will be clean, and hydrogen can act as both the energy fuel, but also as a storage. So it can be a crucial game changer in the future. It may take some time to mature the technologies, but it is still crucial. Carbon capture and storage. Deep decarbonization, meaning that there are some parts like aviation, shipping, but also industry like steel and others that really depend on the fossil fuel. So CCS can be a solution for those, and also to just energy transition. So for countries such as Southeast Asia, we noted that we cannot just 100% change to renewable. We will still need fossil fuel in the next 30, even 40 years. Maybe we shift from coal to natural gas, which is cleaner, but we still need to capture the emissions produced there so we can reach this climate target. Energy storage is very important because, as you know, renewable energy can be intermittent. Solar, wind, the sun does not always shine, wind does not always blow. So to solve that, energy storage will be very important. Lithium-based, pump hydro, but also important here is the flexible grid, because when the the grid can also absorb some of the intermittency. But when you have a very high renewable energy in the future, then the grid needs to be more flexible and smarter. Sustainable mobility, including a vehicle, but also biofuels. Again, aviation, water transport, ships, it's still very difficult to move to electrification, for example. And also clean energy innovation needs to continuously done. Floating solar, floating wind, small modular reactor for nuclear waste to energy. This is still emerging technologies that are still crucial for green energy future. And some recommendations from the AO6 in each of the sector. I already explained most of it, but in power, for example, we need grid improvement. We need demand-side management, energy storage, but we also need to strengthen the emission standard for power plants, especially those that are still using fossil fuel. In transport, biofuel and electric vehicles need to be pushed from the supply and demand side. Public transport will be very, very important. The same with the vehicle efficiency targets. And the last is for energy transition, socioeconomic approach will be very important, meaning like people-centered. Like what would be the impact to this energy transition brings to job creation, for example, those who work in coal, what do we do with them? So it's very important to really understand the centered interests from the socioeconomic perspective. Key stakeholders will be very important, bridging the policy, science, and also community and business. That is like one of the role of ACE. And also to break silo between sector from energy and climate, energy and transport, for example. But what is also, I think, quite important for us to think about is in this recovery from COVID-19 and how to balance that with sustainability. So we do not return to our conventional energy system, which is fossil fuel based, high emission, but something that is more sustainable. So how to balance this short-term target of economic recovery with the mid and long-term target of sustainability will be very important, especially if we want to reach this green energy future. So I think that will be from me. Feel free to reach our website, check our social media to get information on our publication, events, and information related to energy in the region. I'll give it back to Vanessa. Thank you very much.
Thank you very much, Dr. Zulfikar, for the excellent presentation. It surely gives us a bigger picture of how we could apply the renewable energy in the future. So as I seen in the presentation that we still occupy the coal, the oil and gas as the energy supply, but then it starts to in the transitional phase right now, but then it is going to have more input from the renewable energy. Thank you very much. So we are now coming to the question and answer session. If you have any question, please raise your hand. Okay, Pak Yuyun, please.
Okay. Thank you very much, Bu Nisa. Dr. Zulfikar, that interesting topics. I like that. Just explain about the policy of energy in Asia. So my question is, in your prediction and opinion, your prediction and opinion, how long fossil energy like oil and gas and coal still stand to control and dominate in the Asian industry and transport? And then, so when renewable energy will change that? That's maybe my question. Thank you.
Thank you very much, Pak Yuyun. It's a million-dollar question here. I mean, it's a very difficult one. And one that we try also answer with our energy outlook, for example. What I can say is the transition is happening. One very good sign is currently almost all oil and gas company now had some subsidiaries in renewable energy. as you might know. Amina does that, Petronas does that. Like I remember there was this news of oil and gas company in the Middle East. They changed their name from petroleum something into energy something. You know, so even the oil and gas industry tried to rebrand themselves into not oil and gas. I mean, not only fossil and fuel, but also energy. So they have solar, they have wind. You know, they think more about the hydrogen. So I think that transitioning is happening. It will take some time. I think maybe even like in 2050, we are still going to use oil and gas. On coal, probably we can cut it quite a lot. There are a lot of good sentiment and political decisions, I think, to cut coal. But it is still also that we will take some time to transition from to renewable energy. It's even a challenge in developed countries, more so in developing countries like Indonesia and others. But coal will be gone. But then we still need what we call this transition energy. And natural gas is currently starting to show the potential transition energy. So before we move from coal to, then we will have this natural gas, which is quite important, as you know, is in for electricity generation. We need this for the base load, and maybe also the same for industry. So I cannot really say exact year, but the trend is there. How fast it will depends on the politics, more or less, on the decision of policymaker. But the industry also know this, and especially for oil and gas, they start to shift, as I mentioned, to renewable energy. For coal, it might be a bit more difficult, and I suspect this, it can be sensitive, but this struggle between fossil fuel industry and renewable industry will be very important in the next 20, 30 years, which will have a different impact to how the energy shapes in the future. So hopefully that more or less answered your question, Pak Yugen. Thank you.
Okay. Thank you very much, Dr. Zulfikar. Thank you. Thank you, Bu Nisa.
Okay. Thank you very much, Pak Yuyun, for the questions, and Dr. Zulfikar for the answer. It is very interesting, because it is quite an issue for us in having the fossil fuel energy and then shifting to the renewable energy. And then we are going to move to the next questions. We have Pak Duandari that has raised his virtual hand. Pak Duandari, please.
Okay, Teh Nisa, am I audible?
Yes, we can hear
Okay.
you.
Okay, Dr. Zulfikar, thank you for sharing and presentation. It is interesting that based on your presentation, that renewable energy is a good solution to reduce dependence on fossil energy. But then in recent months, many media have reported on the energy crisis in the US, UK, Europe, and even in India and China. Yes, indeed, that those cases prove that the energy transition is not impossible, but never be easy. And possibly for the next 5, 10, 20 years are going to be more complex, costly, and at times very challenging to implement. Actually, I have 2 questions. The first, from your opinion, from the modern energy crisis looks like, how the future energy business model should be. And for the second one, for us in Indonesia and Southeast Asia, what the main lesson learned for the energy transition portfolio from the 2021 global energy crisis? Thank you.
Okay, thank you, Pak Duandari. Very, very good question. A lot of challenging questions today. So yeah, I mentioned as well this energy crisis happening mostly because this supply and demand does not match. It's basically the issue. When you know, as you might know, the supply of oil and gas actually has been decreasing for the last even before pandemic. because the demand is not as this lack of new discovery, and also the available oil and gas did not produce as expected, and worsened in the early pandemic. As you remember, like 2019-20, there are a lot of layoff in oil and gas companies. So the supply is decreasing. And then 2020 comes, and suddenly economic growth is very fast. So the mismatch between supply and demand is actually a very big issue, and a lot of issues in here, a lot of angle, if I must say. One thing, it can be a fair. I'll be honest, it can be a bad precedent for renewable energy. It kind of shows that you still need fossil fuel, otherwise we'll have this energy crisis in the end. And because this energy transition is happening, we don't have enough supply, then you have this energy crisis. Some people can be saying that. And for example, like UK, they are the host for the COP26, which was to champion the energy transition, but then they started to use coal again because they could not have enough supply of natural gas, which is bad PR basically for energy transition. But another perspective is that if our energy mix does not constitute of that much fossil fuel, meaning that we have like a lot of space for renewable energy, then we might not need to be on the crisis because we do not have to be impacted a lot by fossil fuel pricing and by the utility. And once the supply close, like Russia basically one of the big culprit there, when they stop the supply, price increasing. And they start kind of thinking like maybe some regulated market like in Indonesia, our price is more or less stable, right? And might be quite important as well to avoid the same issue in the future. Storage needs to be higher, and then contract need to be better. So there are a lot of solutions from that way. So there are a lot of perspective, and it can be interesting to see what happens in the COP26, for example, and what happens next year as impact of this. So with that as a background, answering your question about the business model and energy transition portfolio. For the portfolio, I would say that more diversification would be best, so we do not influenced a lot by the global energy price. We cannot avoid that, but as much as possible, we need to confine that. So when you are depending on solar, which you can have, you don't care about, you don't worry about the import pricing, then you might be more secure, more sense. So more diversified would be very important in terms of energy portfolio. I think that would be very important. And answering the energy business model, I'm not sure if I have the answer for that. I have to think a bit on that. But I think noting this energy transition moving forward, there are a lot of potential businesses that are coming out there. And what we have to be ready here I'll take example of Indonesia is how we can prepare our industry, our people, to be a key player on those industries. For example, solar and wind. Do we have capacity to produce solar panel? Do we have how good we are in, from geological perspective in mining and processing the rare earth for solar, how good we are in installing, operating and maintenance solar. For electric vehicle, do we have good infrastructure in terms of charging? Do we have capacity, maybe not producing EV, but at least to doing operation and maintenance, etc. So the future energy business model need to consider this energy transition trend. What would be the energy look like in the future? What kind of technologies will be there? What kind of business model will be there? And it's a lot of discussion there, but I think yeah, what I can share is some of the ideas that I have about what it might happen in the future, and grabbing that opportunity will be very important, and that's actually what is currently going on. But it's not enough, I think. Investment in clean energy and related technologies are not enough in the country, and it's alarming because it might be that in the future, when EVs everywhere, when solar everywhere, we are more or less is only seller, distributor, like the end of the supply chain, not somewhere in the beginning. So I think that's a very good question for everyone to think about. So thank you.
And is there any more comments? Yeah, thank you very much. Thank you very much, Ander, for your questions and also the answer from Dr. Zulfikar. I think it is like you mentioned earlier in the presentation that we need to use the green energy for the energy security. So diversification of the energy is the key, I guess. Okay, so we have, I think, one more questions in the chat box. So this is the question from Pak Johannes. Currently, our renewable energy equipment coming from outside, from point of view when Indonesia can manufacture renewable energy equipment, when Indonesia can manufacture the equipment in Indonesia and by Indonesian.
Yeah, thank you, Pak Johannes, for the question. Another difficult question, and I honestly say I do not know when, and I just mentioned in detail of how we should take this opportunity, because we see in the region trend, like in Vietnam and even in Indonesia, it's happening. It will be there. I mean, solar will be everywhere. Will be large part of our energy mix, and I think having the capacity, not in the end of supply chain. So it's not only selling basically, but producing will be very important. And we have good capacity, I think, in terms of manufacturing, even in terms of basic materials, basic minerals. And to do so, I think it needs some. It should coming from the policy first, in the providing proper incentive and environment of investment, so that the private sector can jump in and build the capacity, producing the solar PV. And I think it's the same question when we think about, can Indonesia produce electric vehicle by itself? We have this roadmap by Ministry of Industry and also from electric ESDM on the charging. We probably need to do the same for solar, the roadmap, how we can be a producer, and then we need like specific steps, specific incentives to implement that, because as sometimes policy and regulations and roadmap are not enough. Implementation would be very important. So I think I cannot answer that, but I do know that it is very important, and it will require a strong policy support from government, and also need a very strong implementation strategies to really attract the private sector to build their capacity. And as we found that the jobs related to solar and wind can be huge. It's hundreds of thousands of jobs potentially available in 2040. And it's not only our study. The study by Arena, IEA also mentioned something similar. So yeah, grabbing the opportunities is very crucial if we want to develop in a sustainable way.
Okay, yeah, thank you very much, Dr. Zulfikar, for the answer. So, Pak Johannes, Pak Johannes Johalan, Do you have any more comments or questions? Yes. Okay. Yeah. So I think it is very important, like you have said, that we need the support from our government, especially regarding to the policy, if we want to make this work, I think. So I think there are no more questions in the chat box, or anyone should still have any question. We still have a few more minutes. Okay, so if there is no one have any other question, maybe I have one question, Mas Fikar. This is I sometimes wondered, like the usage of green energy, like everyone wants to shift to the renewable energy, but in Indonesia especially, we still use coal. And you have mentioned earlier in your presentation as well that coal firing is still become the largest part here. And then you also have mentioned that we have the carbon capture and storage technology. So what if we still use that fossil fuel like coal, oil, and gas, but then also implement the carbon capture technology for like the sustainable environment, to sustain the environment, and then for the purpose of reducing the greenhouse gases, maybe. What do you think about that?
Okay, that's quite a good question. And CCS is very promising, but it's not mature yet. There are several pilots on CCS. I think there's one also in Indonesia. So you capture the carbon from the source, and then you can process it somehow. There are some technologies that can process it into cement, something, the C component, or you can store it in geological formations. So it might be like more to your term. So that's why I put it there. So it can be very important in the future, but it's not mature yet. The price is still high. And it also gonna depends on the storage cost. So, you might, people sometimes think only on the capture part, but then once you capture it, you have to transport it and you have to store it in geological formation and ensuring it's always be there. And or also you can also use it in the oil and gas well to inject there. And first, it's not mature yet. It's still quite expensive. And there are some critique on the CCS that says basically what we just discussed. It might push people to still continue fossil fuel. It will give some reason. So we can capture, so let's not push to renewables. So it can give them some time to do so. But actually, even the IPCC, Intergovernmental Panel of Climate Change, which is they produce this scientific report on the climate change, they consider CCS for their scenario, because it's getting harder and harder for us to see a future where fossil fuel do not play a role in the next 20-30 years, until 2050. And we have the strict limit emission target, so we have to reduce that, and we have to have a net zero by 2050 or 2050 basically. And so there's no other way, so we have to go to CCS. So that's basically a very reasonable approach, and that's also done by many, by even the climate change body. But again, there are a lot of works need to be done in terms of maturing the technology. There's not enough research on that. I'm not sure, like even in Indonesia, whether you have research on like potential geological formations for storing carbon. How much will it cost? Because you have to store it there for a very long time. And similarly with other technologies, you might heard about DAC, direct air capture. So you basically you just capture CO2 from the air. Like Bill Gates currently is investing in some of those companies, it's also a part where you realize you're screwed. you emit so much, you cannot transition fast enough, but you need to reduce it. So that's the role of forestry, role of ocean, roles of direct air capture, the roles of CCS. And so the best is you move to renewable energy, you have to mention. But if you still have fossil, then you need to capture. But in my honest opinion, we should not say that let's use fossil because we can capture it. What we have to do is pursue for renewable energy and clean energy. But in case we fail to do so, let's be ready with CCS and DAC. So I think it's the difference in perspective will be very important. Whether you, okay, we don't have to transition, let's just use fossil, we can capture it anyway, but more to let's push the best, but if it's failed, CCS need to be ready. Direct air capture need to be ready because this climate change, we cannot avoid that, like if we continue emitting and doing nothing, it will be catastrophic for even our generation. I mean, it's not only our kids, grandkids generation, even our generation, we might already feel this climate change impact. So so basically, I think it's very logical, but I think the perspective needs to be changed a bit.
So thank you very much for the answer. Yes, I think because I see that Indonesia especially has still a big potential for the fossil fuels. So I guess maybe the need of changing the perspective is still not easy, I guess. So thank you very much once again. Okay, so I think there is one last question here in the chat box from Pak Birian Sagawan. It is said that clean energy for a better life in the future is an obligation. As a member of Asian countries, Indonesia has huge resources of renewable energy. So in order to accelerate energy transition in Indonesia, the GOI had working hard for this issue. From policy side, is there any more to do to make this transition process running smooth and faster? Your opinion, please?
Yeah. So I think incentive and disincentive, fiscal policies are crucial, and it's a sensitive issue actually, because as part of ASEAN, I'm also representing the government to say something about government. But as we know, the market needs to play in the sense that subsidy for energy, especially electricity, so we had subsidy for electricity. And electricity, our electricity is coming from coal and gas. So the price of coal, even though it increased, we keep the price to be limited, right? So the gap is coming from subsidy. So the more we have subsidy in electricity, the more we subsidize the coal. And when we subsidize the fossil fuel, it's going to be saying to the market that fossil fuel is cheap, although it's cheap because of subsidy. So leveling the playing field will be quite important, I think. And you might heard also from news that the new tax regulation, we have what we call the carbon price, carbon tax. It's still quite cheap, I think around 2 cents per ton CO2 or something, something like that. And which is a good point, which can accelerate more on renewable energy. But some people that are kind of saying that you have a tax for fossil fuel, but then you have subsidy also for fossil fuel. So it's like from one pocket to the other pocket. And so this part needs to be played very well in terms of incentive. Moving from incentive, I think, from fiscal incentive, the non-fiscal is also important. And what happened in Vietnam, success case, is they have a very strong feed-in tariff. they also have a very strong supporting policies, including in land acquisition and others. And they also have a very consistent policy. So I think from our discussion with the private sector, what they really need actually consistency. So if you have policy, you're consistent with that. In Indonesia, we had a quite bad experience. Like I don't remember when, maybe 10 years ago, we have a very good feed-in tariff for renewable energy, very attractive. But then after a few years, it is changed. And now our feed-in tariff for renewable energy depends on the average generation cost, which is cheap. So people have no incentive to generate renewable energy. That kind of consistency will be important. So consistency is important. Designing the fiscal incentive, proper fiscal incentive is important. But more than that, the policy related to environment on, how can I say, easier, like import for the renewable energy equipments need to be incentivized. And actually, there's one thing that I want to mention to close, which might not be, how can I say, which might not be sit well for Indonesian as well. But in Vietnam, one of the reasons why they have very high renewable energy, solar capacity increase is they do not have the local content. So even big companies from China, they bring all of their equipment, the people to install it. It's still there, and it's kind of trade-off because, but I think it can still be a good strategy in the beginning. So making sure that the environment in our country is ready, and then from there starting slowly, so we can catch up with the production level. So there are pros and cons, and it's a difficult subject, but I guess consistency, fiscal policy in terms of subsidy, but also in the supporting regulations need to be there. And I think we're in a good way, but we need to accelerate it a bit. Like for example, we have this renewable energy policy regulation law that has been there for the next, I think 2-3 years, hasn't been released yet. So that's also need to be pushed as well. Yeah, hopefully that answered the question. Thanks.
Yeah, thank you very much, Mas Ricardo. I think that's really answering the question. So I think we still have a lot of things, or if we want to move to the utilization of renewable energy in Indonesia, there's still a lot of steps to go there, but hopefully we can reach there soon. Okay, then we come to the end of the presentation. Thank you very much. One more time, I would like to say thank you very much for our invited speaker, Dr. Zulfikar Yulmaidi. We come to the end of the session for today, for the first session. So I'm going to give this back to Bu Kamala.
All right, thank you so much, Mrs. Nisa. And thank you to Dr. Zulfikar for the great presentation about energy. And as our appreciation, we will give a certificate that will be given by Learning, Student Affairs, and Alumni Manager of Faculty of Geological Engineering, Universitas Padjadjaran, Mr. Agustidit Haryanto. Please welcome to Mr. Agustidit.
Okay, thank you, Mrs. Kamala. You hear my voice?
Yeah.
Yes. Okay. Okay. Thank you. So it's we maybe 1 hour and more. We get a very interactive. That's about renewable energy. So if we talk about renewable energy, maybe not finished, yeah. For short time, yeah, because that's I believe the renewable energy is our future next for energy resources. So on behalf of faculty, thank you for your contribution for our international virtual webinar, Pak Dr. Zulfikar. Yeah. I will give you e-certificate for that. And again, I appreciate for your sharing information and insight about the renewable energy. Okay, Pak Zulfikar, later maybe we can collaborate with Faculty of Engineering Geology. Thank you. Again, for audience, thank you for your active participation in our international virtual webinar. Thank you for all. Terima kasih, Ibu Kamala. Silakan saya kembalikan.
Thank you very much, and for all the audience for having me here. Thank you.
Okay, thank you so much, Mr. Agus Didit and also Dr. Zulfikar. For all the participants and also our committee, please turn on your camera so we will take a photo together. Please be ready. 1, 2, 3. Once more. 1, 2, 3. All right, thank you everyone. And for all the participants here, I would like to inform you that this webinar also streaming on YouTube and you can watch later for the presentation of our speaker on YouTube Fakultas Teknik Geologi. And participants who have filled in the attendance form will be given a certificate that can be downloaded at Fakultas Teknik Geologi website. We would like to say thank you to our sponsor for 60 seconds, this Natalis of Faculty of Geological Engineering, PT Kaya Tirta Mandiri, Contractor General Trading and Supplier, Adaro Mining, PT Marwai Coal, PT Raflindo Pratama, Drilling, Hydrogeological and Civil Construction, PT Timah, and Pama Indo Mining. All right, everyone, please, we are at the end of our international webinar series for Green Energy for the Future. Hope this will be a huge benefit for all of us. And once again, I would like to say thank you to all of our keynote speaker and also our moderator. Thanks for sharing with us. And last but not least, thank you for all the participants in this Zoom meeting and on YouTube Live. Don't forget to join us on session 2 at 2 p.m. Indonesian Western Time with Professor Venkatesan Venugopal from University of Edinburgh, because this webinar 4 is not over yet. I'm so sorry if I made mistake. It has been my pleasure to host this event. We wish you all a pleasant day. Thank you for all, everyone.
Thank you very much for all.
Fakultas Teknik Geologi Universitas Pajajaran merupakan lembaga pendidikan tinggi yang menyelenggarakan dan mengelola 3 program studi, yaitu program sarjana dan program pascasarjana yang terdiri atas program magister dan program doktor dengan didukung oleh 8 orang profesor dan 37 orang dosen sebagai staf pengajar. Fakultas Teknik Geologi dengan visi menjadi fakultas yang berstandar internasional dan bermanfaat bagi masyarakat. Salah satu tugas pokok dalam kurikulum teknik geologi adalah menciptakan lulusan yang memiliki keunggulan dalam kemampuan lapangan, sehingga kurikulum teknik geologi dikembangkan secara terpadu dengan muatan desain penelitian, baik berupa pengetahuan, keterampilan maupun pengalaman penelitian dalam bidang geologi, sehingga mahasiswa bebas memilih dengan outcome yang lebih baik sebagai bagian dari program Merdeka Pembelajaran.